successes was.
Dude, we got an AP exam.
That's so many
36 was already
pictures.
awarded as a 10. You know what I'm saying? So do we still have to?
Bryson, what's your question?
You do have
So,
to check it.
Large counts,
I knew we had.
my
to go
number
against
was already larger than 10.
Which number though?
Oh, so you got any ideas of
The
like?
expected amount of successes and failures was
I
already
didn't look
larger.
back at it.
I mean,
I don't know.
So, but you have to write it out to show
But we had
the
to
readers
prove
that, right.
Okay.
So you can't, you have to write it out. You've checked it, write it out to show that you checked it.
Yes, sir.
And there's also in one minus the out. So you have
Is
to
a
check that.
proposal like
when do
a
we do that?
presentation or a?
Well, remember, huh?
Just an idea.
Is it like a presentation?
Use
or
that
a-
one for report.
Well, no, it's a
I think
poster
for
board,
means it's
which
central.
will have,
Okay.
no, the proposal, sorry, are you asking the proposal?
Yeah.
A proposal is just a
Yeah,
written
10%
thing
and-
to submit and say, hey, this is what we're planning.
So we don't have to like go up here and like talk about everything?
Not for the proposal, but for the
Yeah,
final
random.
project, yes.
It legit just says random, and then
Okay.
Virginia's
So the proposal is just a quick write-up of, this is my, characteristic of interest. This is my planned method of collecting that data.
You got any examples of like previous classes?
So this is the first time I've done this one, but I have examples that another teacher did. We'll do that tomorrow, just because everyone will be here tomorrow.
Alright, can you put them on so we know so I can like see them?
Yeah, I got you. Alright. Okay. Huh? Oh, that was a terrible idea. Alright, so let's get started. Oh, did we forget to charge that?
Yeah.
Dang. Yeah, just zoom in as
Be
much
good.
as you can. So here's our agenda, quick notes, midterm plan. Today is Wednesday, so do y'all have to, well, not y'all anyways, I think it was just Haley. Oh, I wanna pass back midterms. Mr. Arliss, can you pass?
Oh, yeah, if the position's on the minute.
Please back.
Oh, yeah, that's right, I did.
Yeah, like you did, man.
So,
I forgot that one thing.
alright, here's what we're gonna do today, so listen, if, my plan is to do some of the, going over the midterm today, okay? During advisory, not during class, because we don't have that time. So, eyes and ears. I'm gonna go over, my plan is the first 12 multiple choice on the midterm as part of our review. The next time we get together during advisory, the next 12 from the midterm multiple choice, and then 1 free response on each day after that. So roughly 4 to 5 advisories. Now, if you did not miss any, or only missed like 1 of those first 12 multiple choice, you don't need to come. But if you missed more than like 2 or 3 on the first 12 multiple choice, you should be in here during advisory today, and I'll shoot your teacher an email. Alright, rewrite of study design analysis. Anyone in here planning on submitting a rewrite so that I can get that graded before I put in final grades for the,
I'll write it.
so email
Not
it to me.
rewrite, I'll actually.
Yeah, email it to me, and send it to me.
When would you need that turned in by?
So if you want it before the actual report cards come out, I need it tonight. If you just want, because here's the thing, if you want to do that so that I don't have to like sign a form or talk to your parents to tell them that you're redoing it, then you can get it to me later this week. But if you want it already in the computer so that it's ready when those report cards come out, I need it tonight, okay? But again, you don't have, if you can't get it to me tonight, then I'll still take it, because I need you to learn these concepts.
So if it gets in, like, let's say on Friday, does it go on the second night?
Oh, yeah.
No, it still is for the first 9 weeks
No,
grade.
oh, I
It's
don't.
gonna be on the
Updated by.
It just won't be updated, but, like, the grade won't be updated before the report cards come out.
Okay.
But I can update it still and, like, write on your report card or send a message to your parents to say, hey, we're doing this resubmission. I've gotten the resubmission, here's the 9 weeks grade.
I can try to get one by today.
Yes.
How late tonight?
Huh?
How late tonight?
Technically, I gotta put the grade in today.
Today or-
So,
So it's not.
here's the thing, if grading, like scoring a final draft doesn't take long because, I don't do feedback, I only do feedback when you have to do a resubmission, which I didn't plan on resubmissions for this one, but, Yeah, get it to me. Now, at the same time, you weren't here Monday during advisory when I went over some key details. Either tomorrow morning or Friday morning, I'm gonna do a second discussion with the final group about what to pay attention to so that you can do a better resubmission. So like, was that helpful? Were you here on Monday? Was that helpful?
Yeah.
Okay, so I would do that and we'll just have to update your grade later. Okay? Alright,
So if we do a resubmission by tonight for the grade book, could we still, if it's not good enough, could we still look at like a second session of like going over it? Could we be there and then read it again?
no, this is the final submission. Three submissions, two sets of feedback is enough. Alright, let's get started with today's lesson. So, last night so it doesn't look like we have any questions from the book work. Is that, like we checked our answers? Or if we haven't checked our answers, we're gonna check them tonight so that we can ask our questions tomorrow, okay? But we're gonna get more practice with it. So here's, I went ahead and did the proportion of the earth that's covered in the ocean. So let's look at this together. One thing I will note is, I'll be honest, I didn't actually remember what the proportion was. I thought it was like, what did I use? Was it 99 out of 146? Does that sound right? Somebody? The proportion of the earth that's covered in the ocean with the globe, was it 99 out of 146?
It was 97 out of 146.
Dang it, I was so close. Alright, so we'll have to update a couple of details. So here's what I did though. We're going to talk today about a 4-step procedure, but I want you to notice how I showed evidence here. So first off, I messed up my p-hat because I couldn't remember. Oh well. But it would just change to this being a 97 out of 146. What's the first thing I identified though? What am I doing with this?
Right, you're telling them what you're doing.
I'm telling them what I'm doing, right? Like, if you're gonna develop a plan, you're gonna tell people what you're doing, write out a note of, hey, this is what I'm doing. I'm doing a confidence interval, right? A 1 sample Z interval for a population proportion. Is it important that I say population proportion here? Yes, why? Because we're doing an interval to estimate or to hopefully capture the what? The parameter, so it's population proportion. What did I do next?
That's the midpoint.
What's the next thing I wrote out? The formula. The formula. Notice this is the generalized formula off of the formula sheet. Writing out that general formula every time will help you, 1, remember it, but 2, to make sure you're, can you put it back on the thing? Help you keep track of what you're trying to deal with, right? Noticing that I said, hey, I want a population proportion here. Writing out this formula, I know my stat is p hat, my critical value, and my standard error. Notice the reason why I wrote this formula out here, hey, focus on the learning. The reason I wrote this formula out right here to start is because what did I do after I identified what I'm doing? I checked my conditions, right? So I checked those conditions there. And so that's a big thing. Once I identify this is what I want to do, check my conditions moving forward. Why does random exist? Why is it important that I have a random sample?
So reduce bias.
To reduce bias. Because if we don't reduce our bias, is our statistic probably accurate? No, right?
It's correct.
Yeah, it is correct. If we don't have a random sample, if we don't reduce the bias, our statistic, it sucks. All right, critical value. Those critical values are based on what type of distributions? Huh?
I need to go. I'll be right.
Guys, critical values, what type of distributions do we have? Normal. So what do I need to check with a proportion for normality? Large counts, right? Expected number of successes, expected number of failures, and yes, I messed up, apparently should have been 97. And finally, to be able to use this standard error formula, what has to be true? The 10% rule, right? The 10% condition, the sample size is less than 10% of n. Now, that is, one note, remember, is only if it's without replacement. If it's with replacement, you don't have to stress it, but 10% condition is always a good thing to check. So, after I've checked my conditions, I've identified what I've got, what's the next part of the puzzle? Huh? Yeah. notice I did have to do some work to figure out my confidence interval now, or my critical value. But I will also note this, if you remember your 95, or your 90, 95, and 99% critical values, that's gonna be helpful. But it's just substituting it into that. So I'll fix this for my interval. So 97, 97, 97. And we can type that in. The one nice thing about this is, am I doing all this by hand? No. I need everyone to pick up a calculator. I need you to calculate the interval to make sure you know how to calculate these intervals. By the way, you're going to want to take home these calculators pretty regularly with this current unit. Huh? The problem I left y'all with last night, the proportion of Earth that's covered in ocean. Let me know if you have questions on this, but we should be finding that interval for the proportion of Earth that is covered in ocean water. Help each other in your small groups if necessary. So remember, once you got it. It depends on the day. This afternoon I have an appointment, but usually I'll be here till 4-ish if necessary. Yeah. Say again. It is a confidence interval, but you talking about the sea level? No, what confidence level are we using? Are we using 99% for this?
That's like the highest you can make it. Oh,
Yeah, we were looking at the number of successes.
I have a legal point.
Yes.
God,
What is
you
the
gotta
number
just like
that you need the number of successes?
I don't know why they use that.
Bro, I said that the experiment was used in being containers, but I wrote containers and then I changed it.
77.
Containers.
Make sure y'all help each other, at least two of y'all have this down.
Oh, yeah, but this is for,
You got containers.
I still got more.
Right over there, let's talk about it. Let's see what everyone else says, if they agree. You're doing the confidence interval based on that same interval to find the proportion of Earth that's covered in the ocean. Come on, put up your paint.
1,
5, 6, 7.
How fast do I want to be?
4 decimal places with proportions, just like probability, you want 4 decimal places. What did you ask?
How confident do I want to
Oh, confident. So I don't know why, but I thought you said precise, 99%.
be?
You can never do 100% confidence.
And standard deviation. 0 to 1.
Even that wouldn't technically be 100% confident. Get great peanut butter like it.
Is it great? Is it below?
Oh, yeah.
Is that 0.99?
Yeah. 100%. So like that's the thing. I think for the most part, everyone through we need to shore up that understanding. Especially the first one. Multiple choice is strong.
Plugging in for 95.
I was good on the first.
There's the last probability question that got a lot of this, but we're gonna talk about that here. Yeah, that's all, that one's solid. But then
This one seems to be.
these two got you. But so this is always the easiest for your response questions, is where you definitely want to get points.
Yeah, because you want 99%.
Analyzing the strong data, but we gotta work on your study design. And probability, yeah. Okay. Hey guys, you're just writing the interval. Don't write C lower or C upper. That's the interval.
That was the best fight I've ever heard.
Oh, I'm so sorry. But we just want the interval. And you don't write this out, okay? You've done all that work, you've written that information out, you're just writing it.
You went to a few of them.
There's gonna be people trying to get in there that have never gone to one.
You're just writing the interval.
You should.
So you don't need the middle.
You should go to the anime club.
What's the lower?
Honestly, they'll be
They're probably trying to get some people.
They still recruiting today.
Come on.
This makes sense now, this makes sense now.
Yeah.
Alright.
What are we dealing with? What type of interval? Okay, what type of confidence interval?
That's one. I know it's one of the
Or that my thing is.
Look at the names.
What am I supposed to, what do you mean?
My
What do you
thing
mean?
is like,
Alright, we have an interval. Then we have samples.
Not really, but I get where it's at.
Yeah, what do you think of Robinson?
Dude, alright, I do like so, so I was chilling with
Look at the names.
and I'm like, I'm bored, so
We
because
talked
we're
about
talking
it
Netflix.
I know, that was yesterday.
No, you gotta retain stuff in an AP class, we gotta
Tell me
retain.
why the dude is trying to like 30 women.
I know.
5 minutes.
But thinking about it gets you there.
all the time.
I'll think about it before the time.
Alright,
It's like,
So,
it's weird though.
confidence interval.
Yeah, like.
I messed up a little bit, but just because I did the wrong sample proportion, but we got 0.5637 and we've got 0.7650, okay? And so that's our interval. Notice that it's just using interval notation, the same interval notation that you used for domain, for range, for intervals of increase, decrease, right? That's interval notation, lower bound, upper bound. And then we do always use parentheses, we never use brackets with those things. So, here's what you gotta pay attention to, is how to interpret it. So how do we interpret this?
There's a 99% chance that the population proportion is between those two numbers.
Be careful about that. I wouldn't use that language of chance because you're going into the idea of probability. And so remember, this interval, this one interval is fixed. Technically not this one, this one. And so either that interval captures the parameter or it does not capture the parameter. We don't want to use probability language when we talk about it. Because what you're referring to is not the confidence interval, but the confidence level. Probability is where the level comes in. We say with the interval that we have 99% confidence, not 99% chance of this happening. With 99% confidence, this interval captures the true proportion and then context. Remember, this is that language they use in the book, and so I'll talk about your idea of probability in just a second, or chance. Go for it.
Can you have 100% confidence?
I don't know, what do you think?
I mean, I don't think so because it's like infinitely like this is like very, very small.
Technically, it can go for forever. Can you ever guarantee something?
0 to 1.
0 to 1. I would say that, like, if you're talking about proportions, it's 0 to 1. That would guarantee it, but how useful is that information?
Not very.
Not very, right? So here's what I will say, and this is what you're thinking about, Ashton, and we need to keep these two things separate. When we say 99% confidence, right, that's talking about the confidence level, right? So when we say, when they ask on the AP exam to interpret a 99% confidence level, what do we mean? Right? We are saying in repeated sampling, in the long run, remember that's where probability comes in repeated sampling in the long run. So in repeated sampling with the same conditions, %, of all intervals. And they, in the book and a lot of other places I've seen this, use this extra language, all intervals constructed in the same way.
Mr.
Yes,
I actually
okay. And by the way, I am recording today, so we'll have that if you miss certain parts, but 99% of all intervals constructed in the same way will capture the parameter. And then you would put context. So this is where the probability language, Ashton, comes up. But it's because in the long run, 99% of all intervals will capture the parameter that I am 99% confident. There is no probability with this interval. And if you use that language of probability with the actual interval, you will not get credit on the AP exam for that part of for the interpretation part. Okay?
Can you repeat that?
So the confidence level is where the probability comes in, right?
Yeah.
In repeated sampling, in the long run, 99% of all intervals constructed this way will capture the parameter, right? That is why we are 99% confident, but there's not a probability of 0.99
Yeah.
of capturing. It either captures it or it doesn't, right?
So is it just saying that like, is it just saying that all intervals that are like, I guess like, I don't know, radii is like the right?
So let's think about it this way, like if I were to take this globe, right,
Yeah,
okay? So if I take this globe here, and I collect 146 more samples, right?
yeah,
146 more samples, then 99% of the confidence intervals, when I do 146 samples, those confidence intervals, 99% of them will capture the parameter. But it's all the intervals that I could possibly do. Or if I do many intervals in the same process, the same procedure, 99% will capture the parameter. You remember, let's also remember, you remember when we did the applet thing?
yeah,
And we did lots and lots and lots of intervals? Either an interval captured the parameter or it did not, when we talk about a single interval.
yeah.
But if it was a 95% confidence level, what percent of the intervals captured the parameter? 95%, right? So that's the confidence level. That if you do repeated sampling, if you do, which we're not going to, let's clarify. We're not going to do this process over and over and over again, because that's a lot of time, it's a lot of effort, that is not the goal. But we know, based on the studies that we've done and the confidence intervals idea, that if I did this process over and over and over and over and over again, in the long run, 99% of the intervals will capture the parameter. Which is why we are 99% confident that this interval is capturing the parameter.
So they're saying if you go like 3 standard errors away from like your sample, then 99% of the time it's gonna capture the true proportion. Okay.
For all intervals, right? Yeah. So if you do multiple samples, right?
Like, so, they're saying like if you do a sample
Right.
and it's like,
So like if I did repeated this sample, so in this instance, we did how many samples?
146. Yeah.
And in our sample, how many times did we get did our finger land on ocean? 97 times. Is that gonna happen every time though?
No.
If I do 146 more, I got 97 this time, what's another option that I could get?
98.
I could get 98, or I could get 99, I could get 100. It's possible, but it's unlikely. I could get 110, right? What is that called? That's sampling variability, right? And so what we're saying is, in the long run, if I repeatedly did samples where my sample size was 146, and I use this critical value, 99% of all those intervals will capture the parameter, right? That's where probability comes in, the confidence level.
Okay.
But this interval, we're 99% confident that the interval is capturing the parameter because of the probability and the confidence level. But I will say this, I would not use the language of probability with confidence intervals or confidence levels. I would say it these ways because, again, you will lose out on credit on the AP exam if you misuse the word probability when talking about confidence intervals.
Okay.
Okay? So be aware of that. So, are you going to use the word probability or chance or anything like that when it talks about confidence intervals? Do not do it. Because either that interval captures the parameter or it does not. Okay? So it's a 0 or a 1 in terms of probability. But in the long run, 99% of all intervals will capture the parameter. So in this interval, we're 99% confident. 99% of all intervals will capture the parameter. So in this interval, I'm 99% confident. Does that answer? Does that clarify? We go with that language and those ideas. Okay? What's your question, Hayden?
Sorry, I'm trying to answer this myself, but.
Yeah.
Why is it 97 instead of 99?
Well, I made a mistake. I thought I remembered it being 99 out of 146, but if we go back to the data, we collected 97 of the 146 samples, right? So I just made a mistake in remembering, because I didn't write it down and I should have. It's called a scrub move that I made. All right, so here's what I want us to do. I want us to take, let's do 6 to 7 minutes, and I want you to tackle this with a group, but I'm going to do something different. I'm going to do a random group.
I mean, we ain't got it,
All right, so Lexi's not here. Obviously, I need to take her out.
Where's she in the movie?
She,
Central.
Oh.
well,
Last night.
she got her GED, but you know,
Oh, is that what she ended up doing?
yeah.
All right.
Oh, we showed that.
Oh, let's do one less group, I guess.
It's not random.
All right. Move to these groups. Let's do group 1 on that whiteboard, group 2 up here, group 3, and group 4. So let's get up, work in these groups to answer that question in the notes. Deacon, you are in group 2. You're on this vertical surface. Bryson, you're in group 4. Yeah, you're already over there with Joseph. So you're gonna be under that group 8 number.
Alright. Which one are we working on?
Let's try 6 minutes, maximum of 7.
Oh.
Talk with each other. Don't forget to bring a calculator. You got a formula sheet just like on the AP exam.
What are we doing? What are we working on?
The bottom question there.
Okay.
Well, you can just work on it up there. And then, so it's just the next page in the notes. Or it's at the bottom of that. Oh wait, hold on a second.
Yeah.
1,018 US
With-
in June 2019.
like
Oh,
80
we're missing a page here.
cents.
I thought that was different.
No, I just opinion, would you?
Yeah, you got it there.
Or.
I was looking at it and it's the part of the next lesson and I was like freaking out.
It's not
Like
like.
an Indian state.
Very.
29% one of each doesn't like stack number.
Say again.
Like 29% one of 18.
So we're taking.
So remember,
Physical.
n times p hat is what you're talking about, right?
Yeah.
Okay, so 1018 times 0.29 is 295.22. There's probably around,
Yeah.
probably 295, but regardless, is that greater than equal to 10?
So we have to.
No, but I was saying for the, because I tried to do this number, here's what I thought I was writing something, but I was like, that
So,
applies to the value, which is kind of.
What's your,
Can we just
well,
push
just,
it
so,
across
hold on.
every meeting?
Z
Yeah, I'm gonna go
times
ahead and
So we
start.
draw this thing.
p hat times 1 minus p hat divided by n, right? So it's p hat.
Why didn't it work in like the conference?
29%.
Oh,
Oh, it should be 295.22.
That's just p hat. That's just the proportion right now.
What?
What number is that?
Oh,
I didn't even know it was
Right.
Wait, how do we do?
Yeah, so
So just-
0.29.
I'm just writing out the
that
formula,
would be
right?
like,
That is p hat.
295.22.
I think I know where your issue is, but hold on 1 second. Hold on. Just trust me. We're gonna write this formula out. Is that a 0.29? Okay. Z star, so you get 1.645.
Yeah.
But that's, so would it just be 295 since it's equal?
So guys, I want y'all to pay attention to this, because y'all are starting to get to the problem that I wanted you to recognize here. Some of y'all get domain error typing this into the formula, right?
Yeah.
Are you putting decimals in for the successes?
Yeah.
Can you have a decimal value for a number of successes?
Well, how are we supposed to round it?
Oh, shoot.
So just round to the nearest integer.
Oh, cool.
Okay.
Right.
So just write that formula out, right? But then on the calculator side of
That's
things,
the, N is the total.
You should just say it like everybody missed it.
go for
And
it.
then we have
We're constructing this off that 29%, right?
It should be what, E star times Standard error.
and then 90%. That's it. Notice of words, you just can't have this.
That's what I got.
Okay,
So,
what's your question?
So we're constructing this off the 29.
Correct.
I have point two six six.
I was wondering where you got
Yeah.
that from.
Yeah.
And you're out.
Hang on, I'll write this down and
Yeah,
then show you.
all the time. In this class, I'm always out of it.
so,
Okay, so large caps are.
Then I put that in.
You have to check the,
So,
here's why. Look,
right here.
if I had,
I mean, you can just
he
type
had,
everything into the.
0.9,
Excessive is 295.
and let's say that n was 50.
What else?
So 50 times 0.9 would be 45. My expected number of successes, does that satisfy large counts? Okay. But remember, I have a total of 50, so what would be the expected number of failures?
I have the wrong number. You're right.
Does that satisfy the large counts? That's why you have to check both expected successes and expected failures. Okay, and just use the calculator for that piece.
so when we finish, we,
Huh?
Same thing.
What's the question?
No.
Like we're
90% confidence
I guess that's.
with all intervals constructed the same way.
Good question, so that's the question.
Guess what he said?
Organization has.
I'm writing down what he said.
Construct and interpret 90%
He said
confidence.
that, I swear, he said something like, with all intervals being constructed the same way, he said that, like word for word. On like the board there.
Are you doing the confidence interval or the confidence level interaction? So you're interpreting this interval,
Yeah.
not the level this time.
what's the difference again?
So remember, the level is if I do repeated sampling, right? So in the long run, 90% of my confidence intervals will capture the parameter. So for this interval, we're 90% confident of what? This interval does what?
Oh, it captures the parameter.
So is the interval a result of the level?
Yes. Yeah. So with 90% confidence, what interval? This one, right?
Yeah.
So we would say the interval 0.2663 to 0.3132
Oh, yeah.
captures the,
Proportion of all U.S. those who favor making CCSA.
see how you put that parameter in context?
US adults who favor.
What did he say about putting it into the calculator?
You have to like not use that inspiration assessment.
No, I meant to put my lunch in the fridge earlier. Let's fix that. There's a nice pack in there, but still.
Whole pizza again today?
And I got extra.
Is that mellow mushroom?
No, this is still Tuscany.
Yeah, I guess we could.
We had that on Sunday when Morgan's parents went to town, but I also had some guacamole. It's not as good as fresh, but it's hard to have fresh the next day.
Bring chips?
Yeah, I'm not just like guacamole.
I know you're putting that in your pizza for a second.
Oh no, that's weird. I don't know how I feel about that.
Not captures the population.
Yes.
Just like
It's a bad, it's surprisingly bad area.
Yeah, it's like really, that's the thing about it, yeah, like, it's like really strange, like,
But
it's not set up like most cities where like, it's like a big size and then like a regular size, so like, it's all, like, it's not even like,
I usually use.
it's that, but like, it's all together, like, you just walk like out the White House and like, in 2 minutes you're in the hood.
That's why I don't do the practice problem.
Yeah.
We have more practice on for real.
And then like on top of that, like, they got like a real bad like carjacking problem. Like, they're worse than like.
Minus the probability. Probability math is not the easiest.
Rating a
That's.
Atlanta just got cute.
Well, we'll get there. We got time. Alright, how we doing?
Like,
We're good.
Yeah, dude, it just.
Alright,
Yeah, I think I wrote.
sweet.
Yeah.
We are 90% confident that the zero captures the true proportion of those like favored.
Like the driver's side door, like completely off, and they got the legs.
Alright. So let's talk about it. We're there. Did everybody get the same interval? 0.2663 to 0.3132?
Yeah.
Wow.
Yeah, they got cute.
Okay.
I was not present in this meeting.
Okay.
Oh yeah, them didn't move.
So,
5 minutes to get down.
really quick note.
Alright, well.
All I need you to notice, because we did well with this one, if you want to write this down, go for it. Personally, actually not personally, it does not matter how you write, hey, Preston, it doesn't matter how you write the interval in the interpretation. You can write it this way as the book does from here to here, or you can write the interval as just the interval. Either way, you're good, right? But remember, use that formulaic approach with 90% confidence. This interval captures, and you can either say the true proportion of US adults that want DC to be a state, or when you were originally saying was the proportion of all US adults, right? Why do we have to say true proportion or the proportion of all?
That way we're setting parameters.
It has to be clear that we are estimating a what? Parameter. We're trying to calculate, or sorry, we're trying to capture that parameter. You have to make sure that the interval clearly is trying to capture a parameter. So, let's talk about this really quickly. What happens when one of the conditions is violated? Any guesses?
Can't estimate the population.
It's probably
So be careful, so let's talk about this. Remember, bias is the idea that if I do repeated samples, then my samples will not be accurate to the population. So if the random condition is violated, then we have to be careful because it's more than likely that our samples are off, right? So bias is only about that random piece. But what else could happen if one of those conditions is violated? I mean, what's the real issue with that? Okay, so 10% condition, we can't use that standard error formula, right? So what do you think is going to happen though if my true proportion is off, or my 10% condition is violated, or the large counts is violated? Like, what is that going to do to my interval? Okay, is it always going to be wrong? No. But you can't assume that it's right. And remember, we can't really assume that it was right here either, right? How confident were we?
90%.
90%. But if one of those conditions is violated, are we still going to be 90% confident?
No.
That's what we would want to recognize. If one of the conditions is violated, our capture rate will be wrong.
So we could not reliably construct a confidence interval.
That's exactly what we'd want to notice, right? If one of those conditions is violated, our confidence interval will not have the correct capture rate.
So is there gonna be a problem where it's, one of the conditions not gonna be met?
So on the AP exam, if they say construct and interpret the confidence interval, I've never seen it not be correct. However, what I have seen them do is in a multiple part problem, ask the question quite literally, so what if this sample size was blank, how would that affect your confidence interval? And you would have to make that argument of, hey, that sample size would mean that my sample is violating the 10% condition, so I could not be as confident or have this correct confidence level in my interval. Does that make sense?
Yeah.
So it's not, if they ever say, hey, construct and interpret a confidence interval, they're not gonna violate a condition. But they do have it set up where maybe they have a multiple part question and they say, well, what if this happens? And you would need to recognize, they're not gonna tell you that a condition is violated. You'll have to recognize the condition is violated and explain why that's a
And you
problem.
still have to, prove and note that the conditions have not been violated in the FRQs?
Yes, yeah, so we're actually about to talk about that a little bit, but what pages was that in the book that are referred to in those notes? It was like 456. 456 was one of the pages, I know that. Or 546?
Yeah.
That one. So 546 up here. Why was that noted? Okay. So there's a note here. No, that's not what I wanted. Ignore that page, I guess. What were the other set of pages?
559 and 561.
559 to 561,
61.
okay. So, there we go. I butchered something in there though, in terms of my notes. I need to go figure out what it was, but it's supposed to be just before that actually, where it talks about, here we go. What happened, so it's page, oh, it is 556. I read something. So what happens if one of the conditions is violated, right? If the data come from a voluntary response or convenient sample, so not random, there's no point in constructing a confidence interval for P, because, what have I said before? It's biased. Our sample proportion is, said earlier,
What, bias?
well, yeah, it's biased, but I said it's crap, right?
Oh, yeah.
If I don't have a good sample proportion, my data's crap. There's no sense in doing anything with it. If you violate the large counts condition, remember, what does the large counts condition check for with proportions? Approximate what? Normality. And if I don't have a normal distribution, can I use the confidence interval idea and look for those critical values? Right? I can't look for those critical values unless it's approximately normal. And so my capture rate will be wrong. If I violate the 10% condition, then again that formula for standard error is going to be inaccurate, and so my data or my confidence interval will be wrong, right? So that's what we want to notice there. So what happens if one of the conditions is violated? That's, make a note to yourself that that's page 546, I think it's on page 6. Right? What happens when one of the conditions is violated? We have an issue, right? The capture rate is going to be wrong. I ate it, sorry.
What?
There is a note here in the book. If you violate the 10% condition, that's what I should have brought up. If you violate the 10% condition, then you're more than 95% of your confidence intervals will capture P. And so that doesn't sound like a bad thing, but literally it's supposed to be what percent confidence? 95%, right? So even if the capture rate is higher than we don't want that, because we want to know the confidence level for that interval, right? So if any of those conditions are violated, then either our confidence interval will have too high of a capture rate or too low of a capture rate. Good with that? Go for it, Logan.
I was thinking like when there was, cause it was 295.22, and I was thinking if you just put them, like put the .22 into the one spot, so it'd be like 29,000.
What are you referring to?
On the first part, where it was the proportion.
Yeah.
29%, that was 295.22.
Mm-hmm.
I put it into the calculator, I moved everything over twice to the left. Why is that upper and lower different than just 295?
So like what you're saying is you did 200, 295.22 like this?
Yes. And I
Without a
made-
decimal?
Yeah, no decimal, and I moved, and I made it 101,000.
So 101,800 like this?
Yeah.
Well, because now you're making your sample size significantly larger, and so remember, your p hat would be the same, right?
Mhm.
Your z-score, your critical value would be the same. Your p hat would be the same. But what's right here?
The proportion.
Sample size. And so you change your sample size. I imagine if you do let the sample size go back to this, I bet it would work, but you'd have to do that by hand. The calculator wouldn't be able to do that because you have to put successes and successes and sample size in, right? And so that's why, because it probably has the same exact middle value for that p hat, but if you divide by a way larger number, isn't that going to decrease your margin of error? That's the issue. Make sense? Yeah, it's a good question. All right. So is it okay to use your calculator to calculate the interval?
Yes.
Heck yes, but what do you need to do first?
Tell them what you're doing.
You need to write it out, show your work, right? So is it okay to use your calculator? 1000%. In fact, I would always use my calculator because it's way too easy to make mistakes typing that formula in. So instead, use your calculator, but set it up using the formulas. So set up your formula, show the work, and just make sure you make a note of that. What do they have on page 560? know I had a note here. So AP exam tip right here. No, that's not what I wanted to get. Oh, here's the, there we go. You may use your calculator to compute a confidence interval for on the AP Stats exam, but there's a risk involved. If you just give the calculator answer with no work, you'll either get full credit for the do step, we're going to talk about that in a second, if the interval is correct, or no credit if it's wrong, right? Do not go calculator only method. You have a formula sheet, write out your formula, substitute everything in, and we're going to talk about one thing in just a second, but show the setup at that point. Alright. Did I skip something? Nope, didn't skip anything, but I didn't have a separate thing on there. Alright, so here's something I want you to understand out of the book. And this is an important thing to make sure you get full credit. There's a 4-step process that the AP exam likes to see. I used to do a 9-step process that was much more detailed in every single thing, but this 4-step is way easier. What's the 4-step process to make sure you get full credit? State. Then what?
Plan,
Okay?
do, and conclude.
Do and conclude. And so pay attention to what this says, and so add that somewhere in the notes. Right, so state the parameter you want to estimate and the what? Confidence level, right? So state the parameter you're trying to estimate. So, good.
I lost the flag football photo. That's what I've been trying to do for the past 30 minutes. Secretary Hart photos, and I'm back to finding
Okay,
photos.
I'm recording. You'll be okay.
Thank you.
All right. So state the parameter you're trying to estimate, right? We are trying to estimate, so trying to estimate the true proportion of U.S. adults that want DC to be a state at what confidence level? It was 90% confidence level, right? And so you state it. You state what you're going to do. Then you plan. What's the big thing with the plan?
That's when you write out like the formulas you're gonna use.
You write out and so I would name the formula, I would write the formula, and finally you're going to check your
Work.
conditions. So notice we're not doing yet. Doing the work is step 3. With the plan is you setting it up to make sure, hey, do I have everything I need? And so plan, identify the appropriate inference method, name it, write out the formula. Because when you write out that formula, remember how the formula helps us remember the different conditions? Because there's 3 conditions, each for a part of the formula. The do, if the conditions are met, perform calculations. And so this is, again, where I substitute into the formula. But do I do all those calculations by hand?
No.
And use a calculator for the interval, right? And then what's the conclude?
Interpret the interval in the context of the problem.
Okay. Every chapter we do with inferences, this is the 4-step process. So from now and through until chapter, I think, like 12 or 13, you state, you plan, you do, and you conclude to some level. So learn that 4-step process. And a lot of it stays exactly the same. So state the parameter you want to estimate, the confidence level, identify the appropriate inference method, check your conditions, actually do the calculations, and then interpret with the conclude. So, notice is this very terribly different than what we've been doing? No. But if you do these 4 steps, you're going to earn full credit on the AP exam. A lot of the AP exam that we have seen so far, they have split the questions into multiple pieces, right? There's been a part A, a part B, and a part C. seen that a lot, on free response. On confidence intervals and hypothesis tests, this inferential stuff, they're not gonna break it down into those parts. They're gonna say, hey, construct and interpret this confidence interval, right? Or run this hypothesis test. And they're going to expect you to state, plan, do, and conclude, and there's point values associated with each of those, okay? So be aware, they're not gonna break these inferential pieces out. You have to know to do those 4 steps. So Tyler, the rest of the guys, they all just came in. There's a 4-step process for confidence intervals that you have to follow for full credit on the AP exam. You state the parameter you want to estimate and the confidence level. You plan, so you identify the inference method, name it, write out the formula, and check your conditions. The main reason I recommend writing out the formula is because each condition is associated with a different part of the formula. You do the calculations, and then you conclude, you interpret your interval in context.
So I guess you could just write like random check, 10% check, do the large counts condition formula, check.
So, yeah, what I would highly recommend doing, just because it takes an extra second, but it's helpful, is circle the word random in the problem context, write random check, right? Because there's no way to really show that you know that. But then with like 10%, I would make the note of, hey, 1,018 US adults is less than 10% of all US adults, or something like that. Or you could just do 10% condition check, but you have to show the work for the large counts. Alright. And we talked about it. Is it okay to use your calculator? Yes. But you have to show the setup first. Alright. This next piece, I want us to look at this really quickly. There is a formula that you can memorize, and the formula is stupid because there's a way easier way that I learned a couple years into teaching AT stats. It talks here in this problem of, suppose you wanted to construct a 99% confidence interval for the proportion of all students at the school who have a driver's license. What sample size would you need to guarantee a margin of error, and that is at most 0.08? What do we know that could help us get there?
We have that formula,
We have what formula?
the,
Yeah, do we have a margin of error formula?
yeah.
Oh yeah, we do. What is the margin of error? So
Square
So it's the z star, right? That's the starting point. The square root is my standard error, right? The margin of error is my critical value and my standard error, all right? And so what's the standard error for proportions?
P hat
P hat
times 1 minus P hat over population, or the sample size.
divided by the sample size, okay? And so we want a 99% confidence interval. Oh, and then we want this margin of error to be what?
1, 0.
Do we want it equal to 0.8 or 0.8?
God knows.
It's at most, so it is,
Less than.
we want it to be less than or equal to 0.08, okay? Anybody know any part of that formula that we can substitute in so that we can solve for n?
You can take out z, you can get z star by using that 0.99 and inverse normal.
Right, so remember, I like to draw it out to help me remember it, but this is one of those critical values we do want to know because it's one that shows up a lot. Does anyone remember this value?
I just looked it up. It's negative 1.64.
This is which one?
It should be negative 1.64.
Not for 99%.
It's 2.575.
2.576 is usually where I go to. Remember, this is 0.99 in the center, right? So what is in the two tails total? 0.01. So if I split that in half, 0.005. Right? So use inverse normal with that area.
It gives you 2.57.
Yeah. Yeah.
Yeah, okay.
And that's where I did the 2.576, right? I don't know why, usually it's 2 decimal places, but like in textbooks I've used in the past, they'd use that 6. They're not gonna care on the AP exam if you do 5.7, 5.8, or 5.76. They'll take all of them. Okay, so there's my z-score. And I wanna know what n is. Can I solve this equation right now, or this inequality? At this point?
No,
Why not?
because you still have the z-score on the, or the z-star on the website.
Not because I have the value for the critical value, right?
Yeah, shouldn't you put it on
You
the
still
website?
have, you still have a P.
I still have a p hat there that's unknown, right?
Yeah,
Huh, any guesses what p hat we could use?
0.5,
0.5? Why?
because it's the biggest of the two decimals. Like if, like when you add, multiply the p hat and the 1 minus p hat, it's the biggest you'll get, will be 0.5 times 0.5.
Is that true?
Yeah.
You know? I don't think I've ever had a student just naturally see that, but let's look at that. 0.5 times 0.5 is 0.25, right?
What does that have to do with the rest of the problem?
Hold on, watch this. What if I did 0.4? What would that be multiplied by?
0.6,
0.6, which would give me what?
0.24.
Ah. Well, what if I did 0.3?
That'd be 0.21.
So notice what Joseph is saying is, if we assume that p hat is 0.5, that's going to give us the most conservative estimate, right? And so because that would give me the largest here, whatever sample size I get is the absolute maximum sample size I would need for this margin of error. And so it asks this question down here, how do you choose a value for p hat when solving for the sample size? Well, if I want to know the sample size, do I have p hat? No, so what's a safe p hat to always use?
0.5.
0.5. So if they ask you to calculate a sample size, the best p hat to use is 0.5. It is what will give you the largest sample size possible. So, great catch on that one. So, if they ask you to calculate a sample size, what p hat are we going to use? 0.5.
Flip page.
So, alright, I want you, using the algebra that you know, to solve for n. So that's all it is at this point. If you understand that statistical component, all you have to do is use some algebra. If you want to work on vertical surface first, go for it. If you want to just do it at your desk, for a couple minutes, work with each other, ask questions, and then we can get going. And I will say this, I see a lot of us already jump into calculators. Guys, I'm not doing any of this just on a calculator. I'm writing this out to make sure that I don't make a mistake. Think about how you're going to solve 0.5, not 0.05. 0.5 is going to be the largest. And you only need the positive, right? You don't need the negative in that case. Remember, the reason why we needed the positive or negative is so that we could add or subtract, right? But all I'm trying to find is the largest sample size, so just use a positive 2.576 there. So guys, right? You have this equation, or this inequality, right? If I was solving this, what's the first thing I could do to solve this equation? Well, remember, I'm trying to solve for this n. Is that 0.08 with the n? No, so what can I do? Not yet. So let me point out, that's what I would do. And I like to use a reciprocal to do that, it just makes it easier. Remember, that this fraction bar literally means division. And so it helps me not get it confused with this piece over here.
I know, I told you I got a log in for the foot, now she's competing. I gotta pull my grade up, 82. Oh, yeah, yeah, it's equal one, that's like 7.
Like a class.
I got a log in.
I think 576.
No more answers.
Oh,
Tyler, Joseph, Ashton, y'all all get your in?
Yes, sir.
Yeah, let me come check in a second.
Okay.
What do you get here? 0.031? 0.031. Yeah, keep working it from there, find that in.
And a half a student, so 259.
I got 259. Probably a difference in decimals.
Say square.
It should look like that.
So what would the sample size you recommend be?
260.
Why 260 even though it's 259.2?
You can't have the fifth of a person.
Okay, so why'd you go down instead of up? Or why'd you go up instead of down?
Because if I went down, then it wouldn't meet the requirement from the,
Would they be damn like? That's like. Will got 258.
it's a decimal.
Yeah, I still round
So,
up to 59.
look,
Like, I
you're
bet,
solving an
like,
equation.
I bet somewhere along the way, like, you
I'm
got
solving-
the decimal,
solving an
you wrote it
equal.
out, and it was like three different places, right?
Like, what I wanna solve for is this.
I just
Yeah.
took
So
stuff.
I'm gonna start
from the
using
calculator.
inverses. Like, the way you solve is using inverses. My end's here, and so like, really what's the last thing happening is multiplying by this. So I'm going to divide by that 2.576. Yeah.
Just based on my numbers, it's correct.
Remember how we said, we talked about the fact that that 0.5 gives you the largest value, so it'll give you, it's like,
We're a big six.
we don't have p
I
hat,
don't have a picture.
but that gives me a 0.25.
That would explain
So,
why.
but if I did like
What's my
0.4 times 0.6, that would give me a
No.
0.
Go ahead for your 5-6 page.
If I did 0.3 times 0.7, that would give me a 0.
So does that?
Oh, yeah,
So
You can
that
borrow
gives me
mine.
my largest
Stop
example.
borrowing, because I don't.
Already covered it up in notes.
Isn't that yours?
0.008 or something like that. Then I'm gonna
Yeah,
square
can't
this.
find it.
Okay, so guys, what I wanna point out and emphasize, I need you to note this. You're solving, how do we solve equations? How do we solve inequalities? We use inverses, right?
Yeah.
So literally just use those inverses, right? Square both sides. That square will cancel out the square root. Ooh, that was awful. You can multiply this if you want, but, and do 0.25 there. Divided by n is less than or equal to. Now this became like a stupid number, right? Yeah, but I would even, 0009. Does anyone know how, and so notice I'm gonna multiply by n, and then I need to divide by this number. Do y'all know how to use the calculator to get the entire decimal instead of just having to retype it?
You just kinda, yeah.
You don't even have to do that. So, if you pick up a calculator for me, right, we have the 0.25 here, right? So do 0.25, do your division symbol, and then just scroll up, hit the up until it's highlighted, the number, and hit enter, and it'll bring it down.
That's crazy.
Okay? So, it's just a way to do it. And you just hit the up arrow until it's highlighted, then hit enter. Isn't that nice?
Like, that's not a sample size.
Really like trivia.
I feel like it's not necessary.
I didn't say it was necessary, I just said it's the easiest. You can make your life harder if you
I wouldn't
want.
say it's that.
I mean, you can say that.
You have to remember that.
I know, it's way harder to remember that than having to do raised to the negative 1. For 1 divided by. Alright, so, hey, you do what you want, but I'm telling you the easiest way to make sure you don't miss credit. Alright, so, really quick note. Yeah. Yeah, not 20. Where'd you get 6.63 from? Why'd you multiply those?
You're not supposed to square?
No.
I thought you square everything on that side.
Okay, let's go back to it. Remember, I did it over there. But really quick note, and then I'm going to answer your question, Deacon. What is the formula for margin of error for a confidence interval for a proportion? Is this formula on the formula sheet?
Margin of error?
Yeah.
Would you just use the regular formula?
So which regular formula?
The entire like Z star and the plus or minus.
So yeah, remember how the formula sheet has something with confidence intervals, right? It says a point estimate, I think, is the language they use.
Yeah.
Plus or minus
Yeah,
the critical value
yeah,
times the standard error.
yeah.
And which part of this is my margin of error?
The critical value.
Okay? And so if we understand this part, we know the critical value is Z star this time. We know the standard error from the formula sheet. Doesn't the formula sheet have that standard error on there? So does it have the formula just right away? No, but does it have the formula? Yes, if you put the pieces together, that formula is on the formula sheet. Okay, and so Deacon, to answer your question, remember, if you are solving an equation, you're going to use inverses. But you want to pay attention to what order to do your inverses in. Because when I am looking at this, I'm trying to solve for this n right here. And that square root is happening before this multiplication.
Yeah.
So I'm going to divide by 2.56. 576. And so I get the square root of 0.25 divided by n is less than or equal to, I think it's like a 0.03018 maybe? Is that about right? And then the last operation on the left-hand side is the square root, so now I square it. Does that answer your questions at this point?
Yep.
So use your inverses, pay attention to the order. Alright.
I still don't get why you use 0.5.
So here's the thing.
Well, which one's most of me?
Well, because you want to guarantee what margin of error? 0.08. But if you do a smaller sample size, you could get a higher margin of error. But if you get the largest sample size possible to guarantee that margin of error, you have that or less. And so you want to have the largest value here to make sure your sample size is large enough.
So, but wouldn't you want to be like safe and make sure
That
that
is the same.
Yeah.
That's what they're saying, that's what
Just
they
the biggest size.
a bigger difference between the two would be safe?
Well, so notice here, this is why we looked at this earlier. So p hat times 1 minus p hat would be 0.25. But what if I did a 0.4? So p hat times 1 minus p hat would give me 0.24. What if I did 0.2 times 0.8? Notice that does give you the largest when you multiply those two proportions.
I don't know like why you want the largest. I still can't grasp why you want the largest.
It's like basically like the bigger it is, because you're trying to find like the, what is it, like the minimum number. So
Yeah.
if you have a smaller number on the top, then that means it doesn't take as much on the bottom to get a certain number.
And so if I let p hat equal 0.4, here's another way to see it. So I'm going to have 0.08 squared. So in this case, I get an n greater than or equal to 249. If I let p hat be 0.3, I get n is greater than or equal to 218. But notice what we got here was that n needed to be greater than or equal to what?
Like 260.
See how letting it be a 0.5 gives me the largest sample size? Does that make sense now? So I just did those calculations quickly on the calculator. But letting that in, or that, yeah, the p hat be 0.5 does give me the best sample size. It guarantees me to have at least that size. That will give me a margin of error at least 0.08 or less. Okay? So 0.5 is the best one to go with. Yes?
You got 260 from solving the equation right above it?
This inequality, yeah. It's because you miss. Wait, what? No, you should have used that number squared. Right?
Well, yeah,
So if you squared that number, hold on, just let me make
yeah, because that's where I wrote that
Oh,
number down.
0.0, that's your issue.
Make your hair,
Yes.
Your hair gets
Careful, you write the hair and the customers burgers.
That's very different, right?
I would assume that is.
I definitely got my first small.
You are very.
Why?
There's like 10 burgers.
Quick note, sorry, I meant to talk about this earlier, we gotta get going, because we gotta get to the next part of this lesson. When you actually calculate it, didn't you get n equals 259.2?
Yeah.
So why did we go up to 260 instead of down to 259?
Because if I went down to 259, the margin of error would be slightly less than 0.8. I mean,
That, slightly more, right? So remember, we want the minimum number of people. If we, even though that's closer to 259, if we go down to 259, my margin of error can be above 0.08. A larger sample size does what to my margin of error? Decreases it, right? So if I want to guarantee that I can decrease my margin of error, I need to go with the larger number. Okay? So even though that's closer to 259, I have to go up to make sure that my margin of error is what I want.
Will got like 258.6, so would he do 259?
He would, but that's probably because you just didn't use, so like you probably typed those decimals out instead of scrolling up and hitting enter to bring it down, that's why.
Does the AP exam account for that?
As long as you show your work. Okay? Alright, so here's some homework problems associated with all these ideas. Again, we check our answers. We need to go over the next, or at least start the next lesson, hopefully get majority of the way through it. So, what's different about lesson 3? Is it right there in that first question?
Two proportions instead of
A 2 proportion instead of a 1 proportion.
Will that be on the, what you call it tomorrow?
The demonstrated understanding? No.
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 This is like.
Okay.
Yes.
Yeah, guys, there's a demonstrated understanding tomorrow that will be through the first 2 lessons. Now, I'll say this though, this doesn't change much at all. Okay? Well, the demonstrated understanding will be at the very beginning of class. So if you want to go to the Powder Puff, you can. However, I will point out that you have an AP exam. I will record class. So it's your responsibility to watch that video and make sure you're ready for class the next day.
Is this at the beginning, you said?
It's, yes.
Can I come in first thing? Sure.
Alright. So what is the name of the procedure we use when calculating a confidence interval for a difference in 2 proportions? Any guesses?
2 proportion, whatever the other one is, but replace the one with.
So if we look on the calculator, what's it going to be called? A 2 proportion
Z.
interval, right? 2 proportion Z interval. That's what the calculator will say. Can you name it that? Sure. Let's see what the book says. You're what? Boom, roasted. Anyways.
A two proportion.
Where's my thing called? There it is.
Or what if it is two samples?
So what does the book call it?
Two samples Z interval for a difference between two proportions.
So the same thing.
But the one thing is, I will point this out. Has anyone thought it weird that they keep using the word Z interval? Like that we need to clarify that?
Yes.
Yeah, that's a little weird, right? Well, it's because when we talk about means, we're going to have to do something other than Z intervals. So that's not this unit, but that's why they do a 2 sample Z interval, create difference between 2 proportions. As far as I'm aware, if you just write 2 proportion Z interval as the name, you'll be fine. But that's something you want to be aware of. Okay? Alright. So,
What, two proportions, you know?
2 proportions interval. That's what's on the calculator. That's what I would name it. Alright, so what do you think the random, the 10%, and the large counts conditions will be for this 2 proportion Z interval? Same thing? So when you say the same thing for both,
You gotta check both of them.
you gotta check both of them. So the first interval the first sample needs to be random, and the second sample needs to be random, right? Like you would have to check both. Now, there's one extra detail we have to add when it's a 2 proportion. Make sure both samples both samples are random. Say that again. And independent. They have to be independent because, and that kind of goes with the 10% as well, but like if one proportion affects the other, you're not really going to get a confidence interval, right? So they have to be random and they have to be independent samples. Okay? 10% condition. What is that going to be?
Normal.
Remember, large counts is normal, but what am I going to write for 10% condition? Like, how would we label this? What is that checking?
That's it.
Independence.
It is checking independence, right? That if we're doing it without replacement, one sample selection doesn't affect the next, but how have I written the 10% condition in the past?
N times P. And-
Not 10%.
or no, sorry.
0.1 times,
And
So remember, my sample size needs to be what?
21 times 11.
So less than,
21 of the population.
so, and it's literally 10%. You need to remember the 10% condition is that the sample size is less than 10% of the population size. That's why we use a big N for population. Less than. It's not really going to make a huge difference, but less than. So N is less than 10% of the population size. But here's the thing, how many samples do we now have? So can I just check it for 1?
No.
No. So how am I going to differentiate the first versus the second?
M1
That's literally what we're going to do. And you can use, and so sample 1 is less than 10% of population 1 size, N2 is less than 10% of the population size for the second population size. You can use A and B, you can use subscripts for the context, but N1 and N2 are common. So what's that going to mean for my large counts condition?
You have to check on both.
You gotta check both, right? So check both counts. Meaning that the expected number of successes, or the number of successes for sample 1, so N1 P1 needs to be greater than or equal to what?
10.
10? N1 times
1 minus P1.
1 minus P1 needs to be greater than or equal to 10. So I got 2 things to point out, and I need y'all paying attention. 1, I made a mistake. 2, why are we doing this? Huh? We gotta remember, if I'm doing confidence interval, do I have P?
No.
Nope, it's P hat every time. And again, what is this checking? What is the large counts condition checking? Normality, right? And so this is only approximately, now remember we have to use that word approximately normal for N1. What else do we have to check?
N2.
Gotta check N2. So N2 times, so expected number of successes, expected number of failures for both is greater than or equal to 10. You got the picture? Man, you got a lot of pictures.
I know, right?
You're just like super cool guy, I guess.
Which one's this?
Very involved in my school book club.
Okay.
Glass
So,
houses and stuff.
the one pain in the butt with 2 sample Z intervals, 2 proportion Z intervals, you gotta check your conditions for both samples. Be aware of that. Okay. Standard error for P1 hat minus P2 hat. Anybody know what that would be? There is a formula. Let's look at that formula. What is that formula? So one thing really quickly, notice I'm going to use this notation for standard error of those sample proportions. It's the square root of
When you P1 times 1 minus P1.
I was gonna use that one. That's when P1 is equal to P2 is assumed. Use the one above it. We're gonna talk about y in a second. P1 hat times
1 minus P1 over N1
divided by N1
plus. Where in the world is this formula coming from?
Standard deviation.
Well, why, how is that the standard, connected to standard deviation?
The standard error is basically.
Standard error is like an estimate of standard deviation.
Okay, but let me ask, let me reword my question. Why is it only 1 square root and why are we adding these two things?
Because you only add the error.
So remember, spread, deviation always increases, but why is there only 1 square root?
Wasn't there only one square root last time?
Not just that.
You want variances.
So remember,
Yeah.
can I add standard deviations or
No.
standard errors?
No.
No. What do I have to add?
Variance.
So I have to add their variances, right? So do not forget, these ideas are gonna always keep showing back up. So the variance is equal to P1 hat times 1 minus P1 hat divided by N1 plus P2 hat times 1 minus P2 hat divided by N2. And that's the variance, right? And what do I do to that variance to get my standard error?
Square root.
I just take the square root. That's why this formula only has 1 square root. So, do you have to know that to use this formula? No, you got a calculator, you got a formula sheet, but this will help you remember that detail from the sampling distributions unit that we did before spring break. So don't forget, variance, or standard deviation. Can I subtract standard deviation?
No.
No, because standard deviation or spread always
Increase.
increases, and I can't add or subtract standard deviation anyways, it's gotta be about the variance, right? It's following what kind of really important theorem you've learned since middle school? The Pythagorean theorem, right? It's a distance, it's measuring distance, and so we're using the Pythagorean theorem there. So what is the standard error measure in it? What is this measuring here?
The estimate of the standard deviation.
So remember, this is an estimate of the standard deviation. Bless you. Of what? Bless you. Standard deviation from what?
The true proportion.
Of the sampling distribution or the proportion.
There you're close.
Differences in proportion.
It's an estimate of the standard deviation for the true difference in those proportions. Remember, that formula tells you a lot. P1 hat minus P2 hat. It's estimating that standard deviation for the true difference.
So it's not the sampling distribution.
That is implied in here, but we probably should add that detail. It's an estimate of the standard deviation of the sampling distribution. For the true difference in P1 and P2. Yeah, that's a good question, but it was implied, but it is better to be clear with that language.
It's like the definition of Shalom.
Do what? Okay. Last detail on here, and again, this is what I want us to really emphasize and point this out. What is the specific formula for a two-sample z interval for P1 minus P2? Let's look at that formula sheet. Let's start with the basics. What is the basic confidence interval formula?
Statistic plus or minus a margin of error.
So statistic, okay, if we look at that formula sheet, I think they break down that margin of error a little bit more.
Yeah, they do. It's critical value.
Critical
plus
value.
standard error.
Times standard error. Well, if I'm trying to do P1 minus P2, what's my statistic? Do they give us that statistic on the formula sheet? So remember, we should be looking under inferential statistics on the backside. Do they give us the statistic?
It just be P hat 1 minus P hat 2.
I would say they don't give it to us, but we know if we're trying to estimate P1 minus P2, the statistic would be P1 hat minus P2 hat, right? That's my statistic. What's the critical value that we're going to use? Yeah, we don't know the value yet, but we know it's some kind of Z critical value. It's based on the standard normal curve. And what about the standard error?
The standard error is that formula we wrote down with the two variances.
Yeah. And remember, it's on the formula sheet. This is a big one. The only reason why I know it is because I've been doing it for a while, and I don't expect you to memorize it. It is helpful to know it off the top of your head, but golly, if you understand this, you can just go to your formula sheet to fill it in. You got a question, Tyler? Just. Okay. Any questions about that formula? Are you going to have to do all these calculations by hand?
No.
Heck no. What are you going to have to do?
Go to menu.
You're going to have to fill in that formula, right? And then you're just going to use the what?
Menu button.
Calculator, right? All right, so let's do this really quickly together because we are running out of time. Here's what I want to point out. I want you to remember, if I'm going to construct and interpret a confidence interval, what's the 4-step process?
Plan.
Before that?
State,
plan, do, and conclude, okay? So I just want us to pick up the calculator though and do the interval on the calculator really quickly. So everybody turn the calculator on. Okay, where are we going to go to do this confidence interval?
Statistics.
We're going to go to statistics, okay? So go ahead and go to statistics. What after that?
Confidence intervals.
Confidence intervals. Which one are we going to go to from there? Notice we have 2 proportion Z interval. So go to your 2 proportion Z interval. And it asks for data or statistics. So it asks for data. We don't have true data there. If you click on the right arrow, what you did 2 sample, hold on. We want 2 proportion. It's not going to ask for that. We want 2 proportion.
Good morning,
So,
please pardon this interruption.
how many
I need to see the
successes
following
do we have?
students at the front desk, please. Cameron White, Rhett Matherson, Jaden Banks, and LaDamian Ford.
Right.
Thank you.
So 0.4 times
Also, juniors, we are
1502.
not meeting today. You're going to be going
That's
to your
gonna give
enrichment
me
and having
601.
further education.
Okay.
We'll catch up with you
It
tomorrow.
was actually 600.8, but I
for our
estimated. And then 0.32 times 1520 gives me 486. Type your values in, type your confidence level in, and calculate that interval really quickly.
What confidence level?
95%. Yeah, it is a 95% confidence interval. So as they give you a lot of values in there, you mostly just need the lower and upper confidence interval values. So don't do B, but what I would recommend you do to help you prepare for your demonstrated understanding is do the state, the plan, and the conclude. Do and conclude for that. So just fill those things out. And you do have a AP Classroom that has been posted, ideally for your sake to prepare for the demonstrated understanding. I would do it tonight. I will not make it due until tomorrow night though. Yes, you can borrow a calculator anytime. So when do we need to have the AP Classroom done?
Tomorrow.
Tomorrow. When do I recommend you get it done?
Tonight.
Tonight. It'll help you prepare for your demonstrate your understanding. Will 8.3 be on your demonstrate your understanding?
No.
No, but all the principles stay the same.